Hello, everyone, and welcome to the Geek Nighter podcast. I am your host, Jelte, and I am back with another very interesting topic and interesting episode. So, I'm joined by Jelte today, who is a core contributor or the main contributor for PG-DuckDB, which is the topic for today. And as you can see, PG and DuckDB both are really interesting. Like Postgres, one of my favorite databases, and DuckDB is like really, I don't know, like really popular these days in embedded databases, mainly for analytics. So we are going to look at and talk about the problem space it solves, how it integrates, what it means for you as a developer, how it works like architecturally and internally and as deep as we would want to go. So let's see. Welcome, Jelte. I'm really excited that we are doing this today. Let's start with a little bit of introduction about yourself, and then we can get started.
Sure. So I work at MotherDuck. It's like a hosted DuckDB in a sense, and there I'm working on PG-DuckDB. Before this, I worked for Microsoft for almost 5 years on Citus and Postgres and PG Bouncer. I still do a bunch of sort of open source Postgres stuff, and that's kind of my background.
Yeah, sounds good. So you said you worked at Microsoft and you were working on like Postgres, right? And how did you end up like joining MotherDuck and then DuckDB, and why did it interest you?
So I mean, two things. I guess it's also always good to sort of. I mean, I was very. I knew a lot about Postgres, or at least I felt I knew a lot about Postgres. So it's sort of good to broaden your horizons a bit and see what else is out there.
Yeah.
And DuckDB was clearly sort of one of the up and coming open source databases that takes a very different approach than Postgres. So that's sort of from the technical side. From the sort of the more social side, it's also because MotherDuck has an office in Amsterdam, and I was working mostly remote at Microsoft, so it was also I also felt like sort of a nice time to sort of be with some colleagues in an office for a while again.
Nice. Yeah, that sounds like fair enough and reasonable. And DuckDB is really interesting. We did one episode, and it was really interesting to learn about it. But if we look at like Postgres and DuckDB, right, and they are like probably traditionally speaking, analytics and transactional databases have been really separate, and you know uh, the line between these two worlds have been getting blurred every day with new technologies coming up. And then we have something like PG-DuckDB, which is like an extension for Postgres. So you can basically have analytics within your Postgres database. We also did similar episode, which is related to analytics using like Postgres database with ParadeDB, which was also solving a different type of problem. So I want to understand. So at a high level, I do understand that, okay, it's an analytics problem that we want to solve in the same database that you have, right? But what is the core problem space that probably DuckDB brings to the table when it comes to integrating with Postgres?
I think there's a few important things that DuckDB brings to the table. One is that it's embedded, so you can very simply sort of load it inside other programs. It's like you can really put DuckDB inside Postgres and like the same process. It fits in the same memory space. So it's running really inside Postgres. It's not a separate database that Postgres needs to talk to over the network or something else. It's just inside. And the other is that it does a very. I mean, it has a lot of traction. I think that's in general sort of one of the key parts is like it has a lot of traction, and that's why it gets integrations with lots of different other systems, because it's like you want to read some stuff from S3, you want to read some stuff from Azure Blob Storage, you want to read some stuff, you want to read Parquet files, you want to read Delta catalogs, you want to read Iceberg. There's a lot of sort of different CSVs. There's a lot of different data formats that you want to be able to read as sort of an analytics database, because people have their data in all kinds of weird formats. And that's sort of where sort of Postgres is not necessarily super good at by default. It's like, okay, it's Postgres is very very strict that sort of everything needs to be in Postgres, and then I understand how it works. And DuckDB is much more sort of a bit more fluid in what it understands. Does that kind of make sense?
Yeah, I think it does. So it's basically like, as I initially said, it's like merging these two worlds and making it easier for the developer to just think about like one system. And as you mentioned, it's a very powerful thing about DuckDB that it can embed within the process that Postgres is running on, and that means I don't have to really think about like the deployment and stuff like that. And then, but DuckDB is again very specialized into analytics, and then we'll get it deeper into how it actually works when it comes to querying and insertion and all of that. But I guess the problem space is clear, that we want to kind of group these things together, so the interfacing application architecture kind of simplifies, right? When you
Yes.
have analytics use case or transactional use case, it's just one interface that you talk to. Cool. So let's get started with this, right? Like Postgres and DuckDB, we understand it's an extension, but how does the architecture look like when it comes to like integrating these? Like if you talk about, okay, I have this extension, now how does the insertion path or the read path would change, and what are the components involved when data is written? So let's start there.
Sure. So there's sort of multiple layers sort of that go back and forth almost in this sort of this architecture. Basically, first the query comes into Postgres, and Postgres needs to then understand the query, because that's sort of what Postgres really wants to do. It needs to know like, oh, it's going to return these types or stuff like this, and it's going to touch these tables. And then once it's done that, PG-DuckDB sort of Postgres allows extensions to run some custom code after it has parsed and understood the query. But before it has actually sort of planned how it's going to get you to your data. So you can say, like, instead of letting Postgres plan this query, what PG-DuckDB does is what we call query stealing approach, which is not what most extensions that do similar things do. But it basically takes the whole query that Postgres got, and then it transforms it into a query that DuckDB will understand. And then you give that to DuckDB, and DuckDB is going to parse it again. And then DuckDB is going to find all the tables. But then some of those tables, they might actually be inside Postgres. So those tables are sort of synced into DuckDB. DuckDB, like there's a sort of a DuckDB extension. Like we have a Postgres extension that contains DuckDB, and DuckDB then contains an extension that can then talk sort of back to Postgres, so that it can get the data from the Postgres tables. And then when it gets that data, it can do all its joins and aggregates and stuff like that, which Postgres is not very fast at in general. Like it's not super slow either, but it's optimized for these transactional like short queries.
Yeah.
Well, DuckDB is really its core purpose is being able to scan lots of data very quickly and doing aggregates and joins and group bys and order bys and stuff like that on lots of data. So the reason we do that is sort of to make DuckDB do as much as possible. So because that's what DuckDB is meant for. So if you want to do an analytics query, it's like, okay, we're going to push as much as possible inside this DuckDB execution engine.
Okay, interesting. So basically, you take the control. You, as in PG-DuckDB, takes the control right after, let's say, the query is validated, and you kind of steal the query. You do the further processing and give it back to Postgres if there is more to process.
Yeah. I mean, there's coming results out of DuckDB, and those then need to be converted into sort of the type that Postgres understands again. But that's really that's the only part, and then Postgres returns those rows to the user, basically.
Yeah.
So there's only a very small sort of interaction layer, sort of like you get the whole query and you give some results back. and then in the middle you might read from Postgres tables.
Okay, that makes sense. And it's basically you're just intercepting, and then only the interfacing part, like the thing that is returned at the end to the user, is done by Postgres, and also the initial query receipt and, let's say, validation. Okay, that sounds good. So high level, I know what is happening there. But let's take an example, right? Like to make proper sense out of it. So let's say I use Postgres and I have, let's say, transactional use cases. I have my orders and regular e-commerce stuff, and I have a huge table, like multiple tables. I run my transactional load. Now suddenly I want to also have like analytics in place, and also in a fast manner. So I want to integrate PG-DuckDB. So I do that. But from the user's perspective, or let's say developer's perspective, how do I configure it? Like, how do I configure DuckDB to start intercepting? And depending on what kind of queries, because not all queries will be routed to DuckDB, right? Because I still have my old transactional workload. So how is that like separated, and how does that work?
All right, so basically there's two mechanisms, kind of. There's one where you can set the setting. You can say like force DuckDB execution, and then any query that you do, it will go into DuckDB. But that's sort of it can improve. I mean that can improve some queries, but it can also make some stuff maybe slower, because if you do like small updates, it's only gonna, like, DuckDB is gonna do more work because it wants to optimize your query better and stuff like that. Than Postgres. I mean, it might take like 20 milliseconds or something instead of like half a millisecond. So for those short queries, I mean, DuckDB is going to be slower. So you definitely. So by default, if you only read from Postgres tables, we will just use the Postgres execution and Postgres planning. But if you can say, like, with a special, like, you can say force DuckDB execution equals true, and then it's gonna run it with DuckDB. So that way you can say, like, oh, this is gonna be I know this is gonna be a slow query, basically. Please do it with DuckDB, because hopefully it gets faster. Okay. That's one way. And the other is, as soon as we notice that whatever you want to do requires DuckDB execution. So in your example, you sort of still had all your data inside Postgres tables. At least that's sort of what it sounded like. You would still have your data all there. So then it would, by default, it would just use the Postgres executor. But if you had stored some of that data, like, I don't know, some old orders from like the last, like maybe not the most recent ones, but have like the orders from starting from like a week ago, you would archive those in S3 as Parquet files, and then you would want to and then you want to sort of merge. You want to merge the current data and the archive in S3 files together, and sort of do some filtering on that, or maybe just query the archive. Then you would have to say in your query, you would have to add a function like select star from read Parquet, and then like the file names, or like the directory, and then a star to sort of have a glob kind of so to get them all. And then because you use this read Parquet function, we know, like, okay, this function, it's only present in DuckDB. It's not part of Postgres. So we sort of get some signal that you want to execute like an analytics query. Or, well, actually, you cannot really execute it even if it was like a single row lookup or something. It's like, okay, well, yeah, that too bad. Postgres cannot do this. So if you do that, then we would, if you do that, then we would run it in DuckDB automatically. And the same sort of holds true if you connect it to MotherDuck. Then you will get some MotherDuck tables sort of merged with your with your regular Postgres tables, and they also require you to run in DuckDB. So that's also what's going to happen there. As soon as you query as soon as you do a query that involves one of those MotherDuck tables.
Okay. I think that makes sense, and that means that, like, of course there are like separate tables that DuckDB hosts and separate tables that Postgres contains, and then probably the table name. There is some convention that you follow for storing analytics, or let's say analytics data for, or data that is suitable for analytics workload versus transactional workload. And then based on the query, you figure out, okay, this looks like an analytics query. Go to DuckDB. This looks like a transactional query, and go to Postgres. That sounds good. What does it change on the application side? Like, is it really transparent for the application in terms of like the existing workload? Of course, for the new queries, let's say analytics queries, I have to change the queries. I have to specifically probably query DuckDB tables. But for the existing workload, I think it's going to be the same, right?
Yeah, the existing workload, it should be. I mean, there's no impact there. The only sort of impact that you might get is that now you're also going to run some analytics queries on your Postgres server, and that can
Yeah.
like those generally use a lot more resources, a lot more RAM, a lot more CPU
Yeah.
than normal Postgres queries.
Yeah.
So that's sort of the one thing to sort of keep in mind, at least when doing this kind of thing.
Yeah, absolutely. We'll get there, like how to keep that balance and what to look at and all of that. So yeah, that makes sense. So from the application, it's just that adding new analytics type of features, I can do that. But for the existing workload, nothing basically changes. And how do I configure these tables though? So for example, I have the orders table and I want to do analytics on top of it. How do I as I said, I already have, like, I don't know, years of data, like a couple of years of data. And now I want to integrate DuckDB and then have this data backfilled in analytics format. And also the new data that is coming in, I also want to, make sure that it's stored in DuckDB as well. So how does that change? What do I configure there?
All right. So for now, there's not we don't have much automation around that. So that's sort of to be made basically. But what you can do is sort of have some periodic query with like a cron job or something like that to say like, I want to insert I want to read from my Postgres table and copy all the stuff that's there, or like all the new stuff that's there to your to your DuckDB, to your mother duck table, or to your parquet files.
Yeah.
Or does that make sense?
Yeah, I think so. So it's basically like running some, let's say, backfill task to kind of backfill all the data, maybe from live Postgres database or even from some backup or something like it's a possibility. I mean, it's still not there,
Yeah.
so it like multiple things are possible. And what happens to the live traffic though, which is like the new data that is coming up? How does it get stored in DuckDB, and what is the format? And let's get some insights there.
So for now, the live sort of live updates, they're not. I mean, sort of the way to support live updates at the moment. We'll eventually want to have sort of replication that it automatically fills in the data into the DuckDB tables as it's coming in. But that's not implemented. What you can currently do though is join, or like sort of union all, like get the DuckDB table and then union all with the Postgres table. And because the Postgres table should be fairly should only contain the recent data, it doesn't matter that it's not stored in the most efficient way for analytics queries, because it's not so much data anyway.
Yeah.
Like that's like DuckDB stores its data in columnar format, which means that if you like, let's say, have 100 columns, and you only query like 3 of them, you're not going to read all the data for the other 97 columns.
Yeah.
And Postgres, it's sort of the other way around. You always you only get the rows that you want, but you get all the columns from those rows. So that's sort of a trade-off in how they're both implemented in their storage format. But if your Postgres tables are not very big, then I mean it doesn't matter. I mean you can read everything, and it's still within like whatever, like a few milliseconds you can read, like let's say 100 milliseconds, you can read all your Postgres data. That's probably good enough for most of your analytics queries.
Okay, yeah.
So if you then join that with the DuckDB tables that are stored more efficiently for your large data set, then it's going to be fine.
Okay. Yeah, that makes sense. And it's obvious that it uses like columnar format to optimize, and it's basically the same DuckDB that we get elsewhere. Like it's the same processing, it's just embedded within Postgres. And now that you can run your analytics query on top of it transparently, because DuckDB intercepts the query and gives you data faster. But as you said, you basically now have like two workloads running on the same machine. So what is the recommendation there? So as we can imagine, it can use a lot of resources depending on the type of data, the distribution of data, and the number of queries and so on. And since it's the same process, how do we as developers kind of isolate these two things, right? Like, because I think talking about the impact perspective, right? Like analytics queries have a separate, like a different impact, while transactional is, let's say, more critical in that sense, because someone is ordering and that may fail, it has a different impact. Someone searching for a product, it has a different impact. So how do I, from the product perspective, how do I isolate these use cases? What is the kind of safeguards I can put in place in terms of allocating some memory or resources specific to DuckDB? Is there some possibility like that?
Yeah, so you can, so there's a few things you can do. Like the most simple thing is to sort of limit the amount of analytics queries you do at the same time. And there's Postgres allows you, like Postgres allows you to say like certain users can only connect like with like 2 or 3 connections at the time, and that way you can limit the amount of queries that are going in. And if only those users can use the DuckDB execution, and then you can sort of limit it that way. That's sort of one part of it, and the other part is then that you can sort of configure the amount of threads and the amount of memory that each DuckDB query is allowed to use. So there's some limits we allow you to put, like DuckDB allows you to put on that, and that we sort of PG-DuckDB also allows you to configure those. So that way you can sort of limit the amount of memory and amount of CPU that those queries can use. But that's sort of one part of this thing. But that does mean that if you're doing the transactional workloads and the analytics workloads on the same machine, that's still sort of can still be problematic. I mean, it might remove some stuff from the cache. So in general, it's sort of more recommended to do it to try to run as much as you can to sort of separate these workloads on a machine level almost. So there's sort of two ways you can kind of do that. One is to use MotherDuck. So you store your data, you store your analytics data in MotherDuck, and then we also do the compute. So we sort of get from Postgres, we then get from the DuckDB inside Postgres, we then get some of the query and we execute it there. And that way, it's a completely separate machine, so it's isolated, and we have some mechanisms to automatically scale up if you get some more traffic. So that can be very nice. And another mechanism is sort of to use like the sort of the Postgres way of sort of doing this. You can have sort of read replicas in Postgres, but that sort of limits your ability to and then write the data. So it's not perfect, but it allows you to at least do sort of the read queries. You just give one separate machine. You say like this is my analytics Postgres. It gets copied from my primary Postgres that does all the inserts and the updates and everything. It gets a copy there, and then I only connect there for my analytics queries. Just that.
Yeah, I mean, fair enough. It's like, I would say, pretty standard approaches that typical Postgres users would try to do, like giving some memory per query, and then limiting per user, like what kind of queries they can run on, or let's say using read replicas, isolating the environment altogether. And I think it's a trade-off, right? Like depending on the analytics, you have to choose your trade-off. One, you get like an embedded database, which is simple to use. It's just one machine, you get everything. But then, of course, there is some limitation. If you run like really analytics heavy workload, I think it makes sense to separate it out, right? And I think if you are more transactional heavy, but you also run a little bit of analytics, it's like the best of both worlds. So I think it's about trade-off, but I think as developers, understanding these trade-offs and understanding the settings is important. And um, yeah, I think it's pretty standard in that sense, which is good, because then a regular Postgres user can do that and can understand what exactly is happening and what are my options. So it's good. What are the key things in terms of like observability? Like, okay, so I understand my Postgres workload. I can look at how the CPU is doing, memory is doing, what kind of logs I'm taking, and all of that. But now I have analytics workload. What is like what metrics do I have when I want to, let's say, debug something? Like, hey, my analytics query is still slow even if I use DuckDB, or it's using more resources than I allotted it, or something like that. So what are different options that I have?
So, I mean, one of the main options DuckDB provides, because in the end, sort of this is all like, I mean, PG-DuckDB doesn't provide many of these like observability options directly. It's more like, oh, DuckDB provides them, and
Yeah.
we expose them again.
Right.
We expose them to the user. So I think the main way of understanding at least why your query is slow is to use explain. So you can put explain in front of your query, and you can put explain analyze to sort of, like with explain you get sort of the plan what DuckDB is going to do, and with explain analyze you get the plan and some timings and some the number of rows and stuff like that to understand what if it's doing something. Maybe it's doing something stupid. Maybe you have a lot more data than you thought you had, stuff like that. But at least you can get some insights into what DuckDB was actually doing. So that's I would say that's the main that's the main approach to for observability at the moment. We have some logging, but that's more for debugging for ourselves at the moment. But yeah, it's
Okay. Yeah, I think so. It basically boils down to what DuckDB provides, and then it's a standard way. If you're already used DuckDB, it's probably pretty used to it. But if not, like you just explain your query, you try to figure out what's happening. And I think the most important one would be to kind of isolate the different behaviors like transactional and analytical, and then start from there. It's good. For like, there are different types of writes, and like some of them are more interesting, some of them are more critical. What happens when I like delete some data? For example, I mean, I have, maybe for GDPR reason, like we live in Europe and GDPR is huge. Like customer wants to delete their data, including, let's say, analytics and whatever data they have. How are these deletes propagated? And when I delete a row for, let's say, a customer, how do I make sure that I also delete it from DuckDB tables?
So the write support in PG-DuckDB is sort of at the moment kind of limited. There's basically two ways of writing. Either you can use copy, like the Postgres copy command to sort of say like, oh, the output of this query, I want to dump it into S3 or into Azure or some blob storage somewhere. And then, I mean, there's a file there, and right now there's no way to then delete that file from Postgres. So it's like it's gonna be there. It's like in your S3 bucket somewhere.
Yeah.
And so if you want to get rid of that, you would have to have some other tooling to delete that from your S3 bucket. The other option is the other write option. The other way to write data is to use the MotherDuck integration, and then you can actually that is more sort of common SQL API where you can do insert, update, and also delete. So you can just do like delete where and then I don't know, user ID equals something. And then it would delete it from that table. And I mean, you can still also use the regular Postgres tables for all your stuff. So I mean, if it's in Postgres, it's also like the way you would delete stuff from Postgres tables.
Okay. Yeah, I mean that's fair. Like PG-DuckDB is fairly new, and like there is a lot of upcoming features. We'll talk about it. But yeah, I think the main thing would be like the tooling around it. Like, how do I do all these housekeeping type of tasks along with DuckDB? And I think those will be interesting to see in the future. Cool. I think this is good. The other problem I have seen, like typically with databases, is like migration, or let's say something changes in the schema. So I'm not just talking about the database, like the version migration, like upgrade, but also the schema changes and all of that. Is it also limited at this point, or is there some like regular migration tooling that's supported?
You mean like adding a column and dropping a column, stuff like that?
Yeah.
So right now because the writing into S3, it's really just creating like a Parquet file or CSV file or JSON file. That there's like, I mean, there's not really, I mean, yeah, you can just put a new one there and there's a new schema basically.
Okay.
And the MotherDuck integration, that's you can create tables, you can drop tables, but if you want to add a column to a table, that's not supported directly from Postgres. You would have to use like you would have to connect to MotherDuck through the UI or through the DuckDB CLI. Like you have to connect directly to MotherDuck basically, and then if you drop a column there or add a column there, it will show up in your Postgres. It's like it's going to be it's going to be synced back. Those changes will be synced, but there's no way to sort of make them originate from Postgres.
Got it.
Only the create and the drop.
Okay. Okay. So this means that when I'm kind of running these let's say join queries across like DuckDB and Postgres tables, I have to be a little bit cautious, because it can be that both are like kind of not in sync in terms of the schema, and then things may fail. So what kind of failures are like gracefully handled within DuckDB versus thrown to Postgres and ultimately to a user? So what are the I guess what I want to ask is, from the user's perspective, what do I need to care about when it comes to like new failure modes when I'm working with these workloads?
Yeah. So, I mean, yes, it's totally the case that if you depend on the columns being exactly the same in both tables, in sort of a like a union or a join or something like that, then you need to be careful that you update both before you start using this new column. Like if you add columns, it's not maybe it's not trivial, but it's also not super hard. You can add one in Postgres, and then you can add one in MotherDuck, and then only then you actually start. If you do your select query and you specify all the columns that you want to select, then you can, if you don't specify the new column, if you don't do like select star, then it's gonna be fine. But as long as if you do like a select star for this kind of putting two tables together, that's definitely then you have to be very careful with schema changes, or I mean, maybe your analytics query only runs like once a day or something, and then it's also not a big deal. You can if you do both with like a minute in between, or like 10, it's I mean, maybe it fails once and it's like, oh, the next time it retries, it's okay. I think that's so that's definitely something that would be good to sort of have a better story around. But it's also it's in a lot of cases, I think it's not a huge problem. as long as you're a bit careful.
Right. I think, yeah. I mean, this is probably the case with like any other workload. You have to make sure that, when you, let's say, delete columns or something, like change something drastic in terms of schema, you have to always be careful that all your use cases are covered. Otherwise, it's let's say, a backward incompatible change, and we have to deal with that anyways in other workloads as well. So that makes sense. In terms of the database upgrades itself, like I want to upgrade, let's say, the new version of the extension, or probably it's the same with other extensions, right? It's not like anything new that PG-DuckDB users have to do.
No, Postgres has commands too. I mean, it's upgrading extensions in Postgres is not super easy either, but there's sort of a general process. You install it sort of on the operating system, and then you restart Postgres to make it pick up the new sort of bits, and then you have to run like alter extension update or alter extension PG-DuckDB update. So then it will update some of the related things.
Mm-hmm.
That's sort of the process. For Postgres upgrades, I don't know if we support them at the moment. There might be. I don't think we have tested them, so there might be some issues there. But that's definitely sort of on my list of things to be like, okay, that's we need to have a we need to have a way to make this work. But for now, it's definitely a bit of an early project, and it's not. It's also not the sort of the easiest way. Like one way that will definitely work is to drop the extension before you upgrade and just recreate it again, because we don't really store many. We don't really store any sort of persistent data in the extension. So it doesn't, like, if you remove it and add it again in the new Postgres version, then it will work fine, basically.
Okay.
Yeah, but yeah. I think. I mean, that's what I'm saying. I haven't tested it, so I'm not 100% sure.
Yeah.
But I would expect that should at least work, and maybe it will actually work if you upgrade sort of the normal Postgres way without removing and adding it again.
Mm. Yeah,
But,
I think that's a valid approach. I mean, and I would assume that, I mean, anyways, any database upgrade like live database, it takes some time. There's probably some downtime. There's, I don't know, a bunch of Debugging connectors. There's so many moving things, and things go wrong. And even if it takes some time for DuckDB to kind of load the data from somewhere else like S3, I think it's probably a fair use case, right? Because I mean, you are upgrading a database, so it's a big activity when it comes to at companies that are supporting large databases. So that makes sense. Cool. I think we have covered like some of the basics of how you integrate, and what are the limitations as of now, because it's a fairly early project. But what's coming up in the future in terms of these limitations, or let's say new features, or I don't know, some problems that you have identified so far, or you could share some stories around that.
Sure. So I think there's like the next release, I think we're targeting for end of January somewhere. So I mean soonish, but and there's two. I would say there's two major changes that we plan on doing. One is to sort of change the way we read Postgres data. Right now we can only like do like a sequence scan, so you actually read all the we actually read all the Postgres data files and look for the rows when we read stuff from Postgres. But we're changing that to sort of use more of Postgres' infrastructure to do these reads, so that it can also use index scans and partition using partition tables, and you can use parallel scanning and all kinds of almost too many improvements to name. All the stuff how Postgres supports reading data. It's like, okay, suddenly we can use it. So I think that's a really big change and feature. Before we couldn't use indexes. Like if there were indexes on a table, we might be a lot slower when reading stuff from Postgres tables because we were scanning everything, while Postgres would be using the index to look up only certain rows. So now we can do that as well. Or I mean, we're merging that hopefully in like 1 or 2 days. That's kind of the plan.
LGTM.
Yes. And the other thing that we noticed after sort of initial feedback on the first the first few versions of the extension was that the way Postgres, the way you would be able to read CSV files and read Parquet files from S3, we would have like this. We have this function, so you can say like select star from read CSV, and then between parentheses you put the name of the CSV file, the path, S3 colon / something. But the way Postgres and in DuckDB that's enough. Like in DuckDB, it's actually even simpler. In DuckDB, you don't even need to read CSV. You can just do select star from and then put the name of the CSV file, and it will sort of magically figure out, oh, it's a CSV file. I'm gonna, because it has a .csv extension, I'm gonna get it from S3. Postgres is a lot like DuckDB is really made for this sort of this easy data exploration. Like, oh, I'm sort of I understand what you mean. Let me go do it. And Postgres is a bit more like, you need to tell me really what you want, because I want to know for sure that I'm doing the right thing. That I'm not doing something that I thought you were meaning, but you didn't actually mean that way. And that's, I mean, there's sort of different, there's different trade-offs in the end for different use cases. But for this read CSV function and the read Parquet function, that meant that for Postgres, you would have to specify all the, like if you do select star from, then you would still have to specify all the types and all the columns that this CSV file would contain. Because Postgres really wanted to know what columns this function was going to return. But it doesn't, it can return anything based on sort of the input. So that's, so that was kind of a confusing syntax a bit to people, because it's also not a super common syntax for that people are used to put the column names sort of to specify the column names in this specific way, and all the types, and it's just sort of not very nice, because you just want to get all the columns, and it's like I don't care what they are, I just want to get them all. So now we have so I'm working on a way to sort of make Postgres accept the query and then have DuckDB figure out what the columns are and then actually fill them in. But that's also planned for the next release. But okay. That's almost finished to be tried by more people. Okay.
Does that mean that now, after this change, Postgres will actually do the query processing and give it to DuckDB for further processing, or how would that change the workflow?
So basically, sort of the workflow will still be the same. Mm-hmm. The only thing is that so Postgres first needs to parse this query, even though it's not actually going to do much with it. Okay. It's like but it needs to be valid Postgres syntax, and Postgres needs to understand what all the types are and where casts are, because when Postgres, one of the weird things is when Postgres parses a select star from something, once it's parsed, there's no star anywhere in the whole sort of parsed representation of this query. It like the star will sort of expand to all the column names. But the problem is that at this state we cannot call into DuckDB to figure out what those column names are. So we have to sort of pretend that there's columns and then get it and then sort of fill them in after the fact. So it's more of a Postgres wants to do a bit more than we want Postgres to do, if that makes sense. But yeah, we don't care that Postgres. We don't want Postgres to figure out the types. We will figure out the types. It's gonna be fine. Yeah. But Postgres really wants to do that.
Yeah, again, I think it's, I mean, you want to integrate with Postgres because, adoption and, people are used to it. So there's probably the downside of it that you have to go the Postgres way and you cannot sort of do it on your
yes.
own way, right?
Yeah, no, and I mean, there's definitely I'm sort of in the background. I'm also trying to sort of make like help push some changes through to Postgres to make this kind of thing easier. But Postgres has a release schedule of like, oh, this is. I mean, this is something you do now. Maybe in 1.5 years, it's actually people can actually use it in production, because they release once a year, and there's half a year of sort of feature freeze and sort of beta and release candidates. So I mean, that's very very nice for sort of this production system. But it does mean that something you do now, it's like okay, we have to do something else now, even though in the future maybe we want to have something like in a better way. I mean, it is open source, but it's very. It takes a long time to make changes to it.
Yeah. Yeah. I mean, for good reasons. Yeah.
For good reasons, yes,
Yeah.
that's for sure.
Cool. What are the like some of the use cases that you really see that people would use PG-DuckDB versus something like, I don't know, like a separate cluster for analytics or stuff like that? I mean, there has to be some, let's say, thumb rule. Oh, if this is your use case, PG-DuckDB is really great. Because I just cannot say, for example, if I have to convince the business that, hey, why don't we use the DuckDB extension versus something else? So what is the, let's say, the selling point or the best use case that would say that, okay, PGDuckDB is really a good use case or a good tool for this? What are some of those use cases?
I mean, so I would almost turn sort of your question upside down a bit and be like, well, you're in a situation where you already have Postgres, but you want to do some analytics. That's kind of so. Yeah. How do then you have to? I mean, like you're starting to do it on Postgres. That's kind of because that's the thing you have. You don't want to add some extra complicated another database system that you have to sync data to, which is, I mean, you start simple and then slowly you figure out like, oh, actually these queries are a bit slower than I want them to be. The stuff is it's just taking too long. I mean, people do analytics on Postgres just because that's where their data is. That's where they start. People don't want many systems, so it's sort of then the next step is to be like, okay, well, the next question is like, okay, we need to fix this. We need to get some faster queries. Well, we can either get some other system and move stuff there, or we can install a Postgres extension and sort of keep stuff here for at least a little while longer while we figure out what our actual difficult queries are, what our needs are. That's so it's that's sort of what that's sort of the. Let me put it like that. I think the primary users are not people that already have like a data warehouse, something else where they do all their analytics queries. Because probably then you're going to do your analytics queries there because you already have it. Like the primary users are the people that don't have that yet and are like, well, I need to do something to make my queries fast. What am I going to do? Well, let's continue to use Postgres for a little while.
I think that makes sense. So, like people who are used to Postgres, they just want to try out or make analytics faster. They can try it out, make it incremental, because simplicity is the key, right? Like the simple the system is, the better. You cannot just say, oh, let me have like another cluster for just analytics, and probably that wouldn't be even used as much as you want if you're just trying out some new features and so on. So yeah, I think that makes sense, and I think incremental approaches probably natural, like how companies also do. Like, oh, I need analytics, let's install this extension. Oh, I'm facing some problems with this extension, let's try to scale it up, like give it a big machine or change the isolation, or have a read replica or something like that. And then they think of having like completely changing the technology, because that's a big commitment, right? Like, because that also impacts the application side, and then So yeah, I think I understand the main use cases. Um, Talking about like, let's say, sort of non-technical stuff. What was the biggest, let's say, challenge building something like an extension for like Postgres with DuckDB?
Non-technical stuff. Um,
I mean,
so
you
that's a,
you
I mean
the
there's a lot
answer
of technical challenges for sure.
yeah, yeah,
Yes.
yeah. The question is non-technical. The answer doesn't have to be.
All right. Okay. Uh, so I mean, there's a few difficult things, I guess. I mean, one of the sort of the technical side of this is like, Postgres and DuckDB are so different. They're sort of their design is so. Postgres is using processes. DuckDB is using threads. Postgres is
Mm,
using C. DuckDB is using C++. There's a lot of these very different technologies that they're using that you sort of have to make work together in a way
mm,
that doesn't blow up. Uh, I think that's the. I would say that's the. Yeah, and like I said before, like the like sort of the strictness versus the sort of the not so strictness, like those kind of things, like yeah, like sort of the different philosophies or designs that these systems are using, sort of marrying those together
mm.
and and making something that works. I think that's sort of the technical part. I think uh, so the sort of the non-technical front. I mean, so we're doing this with a few different companies. We're working on this. Hydra, DuckDB Labs, and MotherDuck are the sort of the main are the main people contributing to the to the extension. I think
Mhm.
sort of this intercompany open source project. That's with everyone sort of wanting different things a little bit, or sort of having. I mean, not necessarily. I mean, yeah, not having different priorities. Let's put it like
Yeah,
that. Not. I
yeah,
mean, we all want the thing to sort of be successful and do fun stuff, but we all have our own area that we're particularly interested in.
yeah.
So sort of making having that yeah having that sort of intercompany uh
Like
way of working.
conflicting
It's
priorities, or let's say,
conflicting. Yes.
okay, that makes sense. I mean, that's a very typical thing to have. Are there anything that like things that you wanted to implement and then later figure out that, oh, maybe this is not going to work, like technically?
Um. Yes. Yeah. Yes. I think one of the. I mean. Most things in the end you can make work technically with enough
Yeah.
time. I mean, there's a couple of. I mean, there's a bunch of things like that theoretically are not possible, but
Hmm.
often like that's not necessarily the area you're working in. In the end, what you care about is like, can I do this thing in sort of the timeline that I want to do it in?
Yeah.
Um, and one of the things that we considered a bit too like that we maybe wanted to do a bit in the start, but turned out to like yeah turned out to be a bit too much work, at least for these initial versions, is sort of having native DuckDB storage sort of inside like having the DuckDB table sort of that also work together with the Postgres ecosystem. Well, because Postgres, when you store data in Postgres, it gets put in the wall, the write ahead log. Any changes are put in there, and that's so any insert, any update, it will get in there.
Yeah.
And then when you do that, it also it's that system is then used for stuff like high availability, like read replicas, that they will consume this wall and then redo those changes and then end up with the same data.
Yeah.
And also for backups, you can sort of start at like some point in time and replay like let's say another hour until you did your drop table, and you get this and you replay the wall until that point. But because DuckDB has its own wall, and Postgres has its own wall, so you need to sort of put all the DuckDB changes inside Postgres,
Mm.
and that's also where this threading and this process problem comes in a bit, because you cannot open the same DuckDB database, like the same DuckDB data file, in multiple processes. And Postgres is multiple processes, so that's also, so you would have to sort of make one DuckDB process that manages everything and sort of communicates back. So it's we have some ideas about how to do this, but it turned out that, well, for this initial version, let's not make it this complicated. This might take, I don't know, a year or more of time to sort of get sort of working well.
Yeah.
It's all not like impossible things, but it's just a lot of work.
Right.
Um,
I mean, given the constraints, it sounds impossible. But if you remove the
Yes.
constraints, everything
Yes.
is technically possible, right?
Yes.
Okay. Fair enough. What are some tips for people who want to contribute to PG-DuckDB? Like how do they get started? What are some, let's say, I don't know, I don't want to call skills, but at least experience would be useful for them to get started.
So I mean, of course, you need some programming experience. That's sort of
Yeah.
That's
a
kind
given.
of
Yeah.
that's kind of a given. But other than that, I mean, I think as long as you, I mean, it depends what you want to change. Of course, if you want to change some really core things, then it's I mean, you need a bit more experience in maybe like DuckDB architecture or Postgres architecture, and those things you can also learn. But for the, I mean, we have a bunch of issues also that are like, we have a tag like good first issue, and those are fairly, I mean, I at least intended to be fairly simple. Like when I looked at it, it was like, I think most people should be able to handle these. Like add support for like a new type. Because like the type conversion between DuckDB and Postgres, I mean, there's a bunch of types, and we support like integers and strings and a bunch of others, and timestamps, and I don't know. But there's also a bunch that we don't support yet. But it's not super difficult to implement. You can sort of you have quite some examples in the code already that do similar things. I mean, you have to look through the DuckDB code a bit. You have to look through the Postgres code a bit, but they're fairly self-contained, or at least intended to be self-contained, and sort of with some related code already there. So I don't think you need a huge, like you need a huge background in databases or anything to sort of contribute to the project. But it is, I mean, in general, at least it's kind of nice if you're a user, I think, or at least tried it out. Like in general, when I contribute to Postgres, like open source projects myself, it's generally because I was using them and I something didn't work. The thing I wanted to do was broken, or it's like, I found some weird bug, or it's like it's missing this feature. So I mean, I mean, if you, and maybe those things are not necessarily the good first issues. Like that's possible. Then you need to put a bit more time in. We have a Discord channel in the DuckDB Discord, where I mean, it's sort of both for users and for people wanting to contribute. So I would say reach out, sort of open an issue, discuss a bit. I think excitement is probably the most important. Like being excited about making some changes, and
be excited or be in pain that this doesn't work, I have to solve it.
Yes. Yes.
Okay. So I'll put the link for the Discord channel so people can actually join the community, get in touch, look at the good first issues, probably try to contribute, learn, use. And I mean, it's a fairly new project, so there's a lot that can be done. There's a lot, as you mentioned, in the roadmap, and I'm excited to see what you build, and probably when it's a bit more, let's say, mature, if I may use that word for this, probably next year or this year, end of this year, when there will be more features, I think we should talk again. Or those features specifically, that hey, now this is also possible, this is also there, and it will be even more interesting. But yeah, I think it's a great project. There's a lot of potential because DuckDB and Postgres both are amazing technologies, and when you merge them, it's you get simplicity with a lot of power, which is really good. So yeah, I mean, I love the discussion. Thanks for joining me today, and yeah, hoping to try it out and also you know learn about the new features that you're building.
Thank you. Yeah, it was lots of fun talking about it.
Awesome. Thank you.